the topic of discussion that we are going to deal right now is we are going to talk about nephrotic syndrome, right? And in this topic, what we'll do is we'll look toward all these notes, we'll be looking toward all these diagrams, and we'll be clear about the concept of nephrotic syndrome. After this topic, the thing that we will be discussing is we'll be discussing about minimal change disease, and that's the example of nephrotic syndrome. Now before getting into the lecture, I would like to highlight this O letter. This O, as you can see, this O, right? I'm highlighting this O letter because the patient who are presented with nephrotic syndrome, right? The patient who are presented with nephrotic syndrome, they show what? They show proteinuria, massive proteinuria, and highlight this O right here. Similarly, the patient will be presented with edema, right? Highlight this O here, right? And other cardinal feature associated with this nephrotic syndrome are our what? Albuminemia, right? And similarly, we have what? We have hyperlipidemia, right? And similarly, we have what? We have lipid in urine, that is lipiduria, right? Lipiduria. So these are what? These are the cardinal features that are seen in nephrotic syndrome. Now here, right? Now here we'll be talking about how these things manifest. Now, what are the cause of having these things? Why we are having all these things? Now here, now there will be because of immune complex mediated damage, right? There can be what? Two way of damage. One can be because of immune complex mediated damage, right? And another damage will be because of what? Because of our what? Cytokine secretion from T cell, right? Now, two way. One because of immune complex mediation, and another through cytokine release from T cells. Now these both will, what they will do is they will release cytokines, right? They will release cytokines. As they will release cytokine, they will provide damage at the level of what? They will provide damage at the level of our what? Visceral epithelial cell, and visceral epithelial cells, what they contains? They contains a podocyte. So the cytokines, now they will cause what? They will cause the damage of podocyte cells, right? Podocytes, right? As you remember, what? This is what? The first one. This is, what is this? The first one. This first one is our endothelial cells, right? These are our endothelial cells. Right here we have what? We have basement membrane, right? Now below basement membrane, what we have is we have what? We have visceral epithelial cells, right? As you can see, these are what? The finger-like projection. These are what? These are podocytes, right? These are podocytes. So okay, what we are saying is that there will be damage in podocytes. These podocytes will be damaged, right? They will be damaged. Now as they will be damaged, what will happen? There will be what? There will be slotting of a podocyte, as you can see right here. You can see there the slot off, right? There is slot off of our podocytes. Now what is this slot off called, sir? This slot off is called effacement. What I'm saying? Effacement. Okay, effacement. Now let us just get back to our discussion point, right? Now what is going on is that as we have said, there will be podocyte damage, right? Podocyte is damaged. Now as podocyte will be damaged, there will be massive proteinuria. Now why massive proteinuria? Okay, now again I would like to take you toward this diagram here, right? These are podocytes. What they contain? They contain negatively charged ion, right? They are negatively charged. As they are negatively charged, right? Now what they will do is they will repel negatively charged substance, and they will attract positively charged substance, right? Unlike attraction and like repulsion. Okay, now protein, if you just protein, what are protein? These are negatively charged one. So normally through glomerular filtration, the protein never filtrates, right? Protein are never filtered, so they are never filtered. But here what is going on is there is podocyte damage. That means podocyte are damaged. As you can see right here, podocyte are damaged. As podocyte are damaged, there will be what? There will be loss of what? Negative charges. So then these negative charges, what they will do is they will now what? They will not repel protein, right? They will not repel protein, and they will what? This protein will be filtered, right? So what we will see? We will see what? We will see proteins, right? Here we will see proteins, right? Proteins. So what we are saying? We are saying there is what? There is massive, right? Massive proteinuria. How much? Greater than 3.5 gram per 24 hours, right? Okay, daily there will be the loss of 3.5 gram per 24 hours. There will be massive proteinuria. I think now it's clear that why there will be massive proteinuria. Okay, now talking about massive proteinuria, the simplest form of protein is our albumin, right? And there will be loss of albumin, right? Albumin will be lost, as we have already mentioned. There will be albuminemia, right? Albuminemia. Okay, now why this albumin is lost? Okay, the first thing that I would like to make you clear is, as I have already mentioned that, right, as I have already mentioned that the negative charge particle in normal condition, negative charge particle are not filtered, right? They are not filtered. These albumin, these are what, these negative charge particle are not filtered, and another substance that are not filtered are the large substances, right? Large substance with a greater size are also not filtered. These albumin, right? These albumin, what these albumin are? These albumin are not large molecules. These are the simplest small molecules. So they are not filtered through basement membrane, or they are not filtered because of their negative charge, not because of their size, because they are small enough to be filtered. So what I'm saying is, albumin was not lost, right? Albumin was not filtered initially, but now the albumin is filtered. Why albumin is filtered? Because now there is damage of what? Podocyte. As podocyte is damaged, there is loss of negative charge, and there is nothing to repel our albumin, so that it will what? It will be filtered, and it will be appearing in what? It will be appearing in our urine, right? Okay, now another thing, okay, so there will be the loss of albumin, right, through our urine, and there will be also loss of another protein. And what is this protein, sir? This protein is our what? This protein is the protein that is so important, right, for what? For excreting our sodium and water, and that is our ANP. Now what is this ANP, sir? This ANP is nothing but this ANP is what? This is atrial natriuretic peptide. Atrial natriuretic peptide. Now what is the function? Normal function of this atrial natriuretic peptide is that it helps in excretion of sodium and water. So if there will be excessive loss of our this ANP, right, there will be excessive loss of our this ANP, then what will happen, right? There will be what? There will be less excretion of sodium and water. That means they will be accumulated in our what? In our tissues, right? In our tissues. So what will happen? There will be the condition of edema. So yes, another point, right? Another cardinal feature. Okay, we have covered what? We said about proteinuria, right? We said about albuminemia, right? We talked about what? We talked about edema, right? Okay, now similarly, okay, another reason for edema to take place is that, right, as we have said that there will be what? There will be excessive loss of albumin, and we know that albumin, what is this albumin? Albumin is the factor that is maintaining oncotic pressure, right? Now if there will be the excessive loss of albumin, then there will be what? There will be decrease in oncotic pressure also, right? And if there will be decrease in oncotic pressure, then the fluid have tendency to what? To migrate to our interstitial spaces, right? Decrease in oncotic pressure means what? The now fluid have tendency to migrate into interstitial spaces. As they will migrate to interstitial spaces, there will be what? There will be edema. So yes, edema results because of two mechanisms right here. One, because of decrease in ANP, right, that was causing decrease in sodium and water excretion, or we can say there will be what? Retention of sodium and water in tissues, that will result in edema. And another mechanism is that there will be reduced in albumin level, that will cause reduction in oncotic pressure, and that will cause what? That will cause that will cause tendency of fluid to move into interstitial spaces, and that is what edema is. But out of these two conditions, these ANP, right, our ANP, because of increase in accumulation of sodium and water, is the most dominant one. So this is what we need to know about edema. Now moving further, now another thing that we need to know is, we need to know about our what? Okay, as there will be what? As there will be damage in podocyte, as there will be podocyte damage, right, there will be what? There will be loss of protein, as we have already said. Podocyte damage means there will be loss in protein, right? And along with protein, as protein will be lost, right, there will be what our body, there will be less amount of protein in our body, and at that time what liver will do is liver will try to compensate that condition, and it will increase its activity. So there will be increase in activity of liver. As liver activity will be increased, it will cause the excessive production of lipid also, and the level of lipid will be increased in blood. Okay, now level of lipid will be increased in blood, right? It will be increased in blood. And similarly, as we know, right, what is this okay, as we know, this is our, okay, let me draw this one. What is this? This is our hyaline cast, right? Normal hyaline cast, that is physiological cast, that is what, that is our horse stem, right? Horse stem for cast, right? Now what will happen in that, in this hyaline cast, there will be, right, since there is high lipid in blood, in this cast what will happen, there will be what, there will be deposition of fats, right? This lipid will deposit in this cast, and when there will be lipid deposition in this cast, now this cast is called lipid cast, right? And what I'm saying is this will be called what, this will be called lipid cast, right? And these will appear as what, this will appear as oval fat body. So oval fat body, right? Now what will happen is that if you just see this oval fat body under polarized microscope, right, polarized microscope, then we'll see that the shape of these what, these oval fat body will be star like, right, like a cross, so the cholesterol esters, right, the cholesterol esters, right, here will look like, will have a cross like appearance, right, as you can see right here, the cross like appearance, and these cross like appearance is called what, Maltese cross, Maltese, Maltese cross. So Maltese cross is the feature of our what, it is the one of the feature of our what, our nephrotic syndrome. But this Maltese cross, it is not just seen in our what, nephrotic syndrome, it is seen in other different condition also, right? Okay, in other different condition also. Okay, now these Maltese cross, these are what, these are what, these Maltese cross will appear in urine, right? These Maltese cross, or these our oval fat body will appear in urine, and that will be called what, lipid urea, right? In urine, that is what our what, that is what, that is our lipid urea, and it is seen in what, nephrotic syndrome. So Maltese cross in urine is seen in what, it is seen in what, it is seen in our nephrotic, right, nephrotic. Similarly, it is also this our Maltese cross is seen in urine, right, in the case of our Fabry's disease, right? And this Fabry's disease in urine, right, in urine, it is also seen in our what, Fabry's disease, right? And this Fabry's disease, what is this? This is an example of lysosomal, right, storage disease. What is this? This is the example of lysosomal storage disease or disorder, right? Okay, now but here in the case of our Fabry's disease, the characteristics finding is our what, mulberry appearance. If you remember, mulberry appearance. Now here, right, these our Maltese cross, it is also seen in the case of our what, in our RBC also, right? And it is because of what, parasitic infection, that is Babesia infection, right? Parasitic infection, that is our Babesia infection. Okay, yes, we are talking about Maltese cross, that it is not the diagnostic feature of our nephrotic syndrome, right? It is also seen in different other condition also, so we need to know very clearly about that thing. Okay, now, okay, as we have said that there will be what, there will be excretion of lipid in urine, and that we were calling as what, that we were calling as lipid urea, right? Lipid urea. Yes, so we talked about what, we talked about lipid urea also, right? Okay, now let us move again right here. So we talked about what, we talked about what, proteinuria, we talked about edema, we talked about albuminuria, we talked about hyperlipidemia and lipiduria, right? So these are the things, now moving further, right, moving further in detail, the thing that we need to discuss right now is, okay, let me see okay, now the thing that I would like to mention right here is, since we were talking about what, we were talking about different protein that were lost because of damage in podocytes, right? Here the other protein that are also lost during the time during this time, and they are transferring is also lost in huge amount. And we know the function of transferrin is to carry what? Iron, right? Iron to hemopoietic tissues, right? If there will be loss of what? Our transferrin. If there will be loss of our transferrin, then what will happen? What will happen? What will happen? There will be the condition in which there will be no transfer of what? Iron, right? There will be no transfer of iron. As there will be no transfer of iron, what will happen? What will happen? The person will suffer from what? Iron deficiency anemia. And this iron deficiency anemia, it is a bit peculiar because it is iron resistance. That means when we provide something to treat this iron deficiency anemia, then at that time the patient will not be cured, because as we are providing externally our iron, these irons, the one that carries this iron is itself in low amount, right? The carrier of this iron is in less amount. So it doesn't matter how much we give, how much we supply iron, because it is iron resistance, because the carrier is itself in low amount. So transferrin will also be reduced. That will give rise to iron deficiency anemia, and that is iron resistant type. Similarly, there will be decrease in what? There will be decrease in vitamin D also, right? D also. Okay, there will be there will be deficiency in vitamin D, right? And so there will be what? There will be what? Low calcium serum level, right? In fact, there will be what? There will be low level of vitamin D binding protein, that will cause low calcium serum concentration, right? Similarly, there will be decrease in what? Immunoglobulin also. There will be decrease in what? There will be decrease in our antithrombin type 3 also. Now, as there will be decrease in antithrombin type 3, right? Antithrombin type 3, what will happen, right? What will happen? There will be the condition in which there will be no dissolution of clot, right? There will be no dissolution of clot, as clot will not be dissolved, right? Because of this low level of antithrombin, there can be the condition of hypercoagulability, right? Hypercoagulability. And these hypercoagulability condition may give rise to what? Deep vein thrombosis. Similarly, what? Renal vein thrombosis, right? Similarly, our what? Pulmonary thromboembolism, right? Pulmonary thromboembolism. So this was about the different protein that are lost in the case of our what? In the case of our this nephritic syndrome. Okay, now here, let's talk about what? Yes, okay, let's talk about what? Let's talk about podocyte in detail a bit, right? Now here, right? Okay, let's talk about podocyte damage. Yes, we already discussed something about podocyte damage, right? Podocyte damage. As there will be podocyte damage, right? Podocyte damage, and these podocyte damage can be mild damage, and also it can be severe damage. As there will be mild damage, right? As there will be mild damage, right? This mild damage, there will be loss of albumin only, right? That means there will be loss of albumin only. Since we are talking about specific one protein, so it is selective proteinuria, right? Selective proteinuria, loss of only low molecular weight protein, and that is albumin, right? Now it is what? There will be response of it will be responsive to steroids, right? We can treat the patient by providing steroid also. But here in the case of severe, right, what will happen? There will be loss of what? There will be loss of albumin, immunoglobulin, protein, right? Antithrombin 2, everything that we discussed earlier. Okay, there will be what? There will be loss of all these things. As there will be loss of all these things, these are non-selective proteinuria, right? No matter of what, irrespective of nature of substance, the substance will get lost. Now it is not so responsive to steroids. Okay, now moving further, I would like to move toward one important discussion, and it is right here. Okay, now as we have already said, what is this? The upper one, this is our endothelium, right? This is our basement membrane. And what is this? This is our what? This is our visceral epithelial cells, and with podocytes, right? Now if you see podocyte, what are these what are present right here? Okay, I think it is more detailed diagram than this one. Okay, right here. Okay, now right here. Okay, what is this? This is our diagram, right? This is our diagram. And if we zoom in these part, right? If we zoom in these part, and we'll just find this one, right? This structure. So here what you'll see is there is what? Here what you'll see is there you can see what? 2 podocytes, right? You can see 2 podocytes. Okay, now here if you see the various component of podocytes, what you'll see, there is nephrin, right? This green one is structure, right? This purple one is structure is our porosine, right? And CD2AP is our this light blue one structure, and these actins are right here. Okay, now this nephrin and podocin, right? We need to know a bit detail about nephrin and podocin. These nephrin, what are these nephrin, right? These nephrin are produced by the activity of NPHS type 1 gene, right? Nephrin are produced with the help of this because of the activity of NPHS type 1 gene, right? And if there will be any defect in this NPHS type 1 gene, then there will be the condition of what? Congenital nephrotic syndrome. Okay, why I'm saying congenital nephrotic syndrome is that congenital nephrotic syndrome, right? Now, okay, as I'm saying, if there will be reduction in what? Reduction in activity of NPHS1 gene, right? And as NPHS1 gene will be reduced, there will be what? There will be less production of nephrin. There will be less production of nephrin, and as there will be less production of nephrin, as you can see, these nephrin, right? These nephrin are responsible for what? These are responsible for blocking various substances because of negative charge within them, right? Because of negative charge within them. So as there will be loss in nephrin, there will be what? There will be massive proteinuria, right? Massive proteinuria. Okay, now this condition was for the first time found in Finland, right? It was found for the first time in Finland, so it is also called Finnish type mutation, not finished indate. It is what? Finnish according to country name mutation. So it is Finnish type mutation. So this was about what? This was about our what? Nephrin. So it is important. So it is important. I'll relate it later on to you. Now talking about podocin. Podocin is produced because of what? NPHS2 gene, because of activity of NPHS2 gene, right? Now if there will be problem in this NPHS2 gene, then there will be obviously no production of podocin, right? Now this, if there will be problem in this NPHS2 gene, it is associated with chromosome what? Chromosome 1q, right? It is associated with chromosome 1q, and it will give rise the condition of focal segmental glomerulosclerosis. Now what is this? We'll be having separate lecture on this focal what? Segmental glomerulosclerosis. Now this, okay, this focal scleroglomerulonephritis, it is what it is, one example of nephrotic syndrome, and it will be what? Found in aged people, right? Aged people. Now one thing I would like to correlate right here is, the thing that we need to know here is NPHS2, right? This 2, just underline this 2, and this in second number, what is present in our this second number? What is present in our second number? It is P, right? It is P. So that means NP type 2 gene will code for what? It will code for podocin. Similarly here 1, right? Here 1, NPHS1 gene will code for the first letter, and that is what? That is our nephrin. And this N, right? From this N we can just say, we can just correlate that it is found in congenital, right? It is congenital nephrotic syndrome. This, from this congenital, we'll just write newborn from N, right? Newborn from N. So from N we have got what? First NPHS1, nephrin, and newborn congenital system, and NPHS2 what? It will just what? It is related to what? Podocin from P, right? Okay. This was about what? This was about nephrin and podocin. Now the thing that we need to know here is, okay, let me see something. Okay, now let us go toward the diagram. Okay, just I would like to, okay, here it is mentioned. Yes, as you can see, right? Podocyte, it consists of what? Nephrin, right? And podocin. Okay, the nephrin is what? NPHS1 gene is associated with nephrin, right? If there will be mutation in NPHS1 type gene, right, and what will happen? There will be nephrin deficiency. If there will be nephrin deficiency, it is what? It is congenital or Finnish nephritic syndrome, right? Finnish nephritic syndrome. Similarly, NPHS type 2 gene mutation, it is what? It is related with podocin deficiency, and there will be what? Focal segmental glomerulosclerosis, and this will be detailedly studied in next what discussion. Okay, now here I would like to take you to a diagram. As you can see here, child, right? As you can see, what is this? Periorbital edema, right? Periorbital edema, and this is, if you see, child with edema, right? If you see child edema, especially in periorbital region, then we'll just say that it can be a patient of what? It can be a patient of our nephritic syndrome. Similarly, what we will see is there when while urinating, we'll find is there will be a lot of frothiness in what? In urine, right? Frothiness in urine, and this is because of massive proteinuria, right? This is because of massive proteinuria. Now similarly, as you can see, right, there what you will see is there will be what? There will be lipid cast, as you can see, right? It's not clear, much clear, but okay, there will be lipid cast, presence of lipid cast, right? Lipid cast, and that is the feature of what? Our nephrotic syndrome, right? Now similarly, another is that, right, as you can see, what is this? This is our what? This is our oval fat body, right? Oval fat body, as we have said, right? A feature of nephrotic syndrome. And similarly, as you can see in immunofluorescence, what you will see is there will be cross like appearance, and that is what? Multi-edge cross, right? It is observed in polarized light. So this was about what? This was about our nephrotic syndrome, right? Nephrotic syndrome. Let me see if something is remaining. Okay, I think it's clear. And in what? In first aid, okay, our trend was that we were also going through the content of first aid, but here I don't see, okay, but here there in first aid there is nothing detail mention about nephrotic syndrome, right? It is just written this much: nephrotic syndrome. It is just underlying O, and it is saying that there will be massive proteinuria greater than 3.5 gram per day. And but there is detailed discussion about what? Our minimal change DGs, that we will be covering in next lecture. So this much for this lecture. Thank you and have a great time.